Today we got a pretty, I wouldn't say challenging video, but you need to lock in. Just get locked in. And I think what will help is if you understand that we're modeling two-step linear equations. We have a video about modeling one-step linear equations. We have a lot of videos about solving equations, but this one we're modeling two-step linear equations. Okay, so get locked in like a fish. So what do you get when you cross an elephant with a fish? You get swimming trunks. I'm not sure if you guys got that one. Elephant and a fish. Well, a fish swims and an elephant has a trunk, swimming trunks. Get locked in. Come on, get focused. I can model and solve two-step linear equations in one variable using a variety of concrete manipulatives and pictorial representations. In other words, you can model solving two-step linear equations. All right, so let's talk equations just as a refresher. They're like a balance. So I want you to think of a balance when you're thinking of an equation, and the balance point, which is that brown triangle there in the middle, is actually an equal sign. So in order for that balance to stay balanced, each side has to have the same value, okay? So just like a balance, equations need to keep the same value on each side. So if I had a balance like this, and I had a 5 and a 6 on one side, that equals 11. And on the other side, I only had an 8, that means this is not balanced. So what would happen is the 5 and 6 side would become unbalanced. But how could we show the balance? Well, it's missing something. And in equations, when we don't know what something is, we call it a variable, okay? And in this situation, we'll go ahead and call our variable x. It is the unknown, even though most of you are looking at it and saying, Tal, it's 3. I know it's 3, but we're just trying to figure out how to show an equation, okay? So on one side is x plus 8, and on the other side is 5 plus 6, and they're going to equal 11. All right, so the keys to understanding how to solve equations, the first one is inverse operations. You have to understand an inverse operation. So in other words, addition and subtraction are the opposite. Inverse means opposite. They are opposite of each other, so they are inverse operations. And you guessed it, multiplication and division are also inverse operations because they are opposite of each other, okay? The next key is the flippity flip order of operations. Flippity flip. That's a fun thing to say. So when we simplify expressions, meaning something without an equal sign, just an expression, we use gemdas. Okay? When we're using equations, we're going to flippity flip gemdas. So remember gemdas? Groupings, and then exponents, and then multiplication and division in the order that you see them, and then addition and subtraction in the order you see them. Flippity flip. We're going to do it backwards. We're going to start with addition and subtraction and move up to multiplication and division, okay? The third key is balance. Remember, when I use my inverse operations on one side, which we're going to show you in a second, I must do the same on the other side so it stays balanced. In other words, you're going to hear me say this a lot. What I do to one side, I must also do to the other. The same thing. And then 4, we got to make sure we understand the parts of an equation. Okay, so here's an equation, 7x minus 3 equals 18. The 7 is a coefficient. It's the number attached to a variable. Okay, and notice that we did 7x and not x7. The coefficient goes before the variable. Next up, we have a variable. That's the unknown. What is the x? I don't know. It's a variable. Next, we're going to have the constants, which are the numbers that don't have variables, the negative 3 or 3 and the 18. Next up, the operator. What are we doing in this problem? If that shows up, it's a minus sign in this case. There's another operator in here that is invisible. When you put a coefficient next to a variable, you get multiplication. Okay, so that's another situation there. And then finally, all of these are terms. All right, I want to make sure you understand those because when we get to the next layer of equations, you're going to have to do this thing called combining like terms. And terms are numbers that kind of go along with each other and match. Like I think of them as teams. So this is a coefficient with a variable. That's one term. This is a term, all right, because it's being added or subtracted. And this is a term. It's on the other side. And when we get to combining like terms, we're going to find the ones that have things in common. Not yet. Not yet. Okay, so modeling two-step equations. So we use algebra tiles to do this. And they are square and rectangle blocks. The squares represent the numbers. An open square or an empty square is 1. A filled in square is -1. Same thing with the variables. An open rectangle is a positive variable and a filled in rectangle is a negative variable. All right, so we use a key. So here's our key that we're going to use. and we're just going to make it smaller when we do these situations, okay? So we're going to refresh the one-step equation right now. So if you haven't seen this old video at all, you might want to go watch it, but I'm going to show you a brief understanding of how we solve one-step equations, okay? So one-step equations is we take a look at what we have. X plus 3 equals negative 5, and we have a positive x and we have a positive 3. So we put a positive x and we put 3 squares to show the positive 3, okay? And then on the other side, we have negative 5. So we put 5 of the negative ones to show negative 5. Everybody with me so far? Groovy! Next up, to solve, the whole goal of solving equations is to isolate the variable. Get the variable by itself. He wants to be lonely. Get everything else over on the other side of the equal sign. So in this case, we have a x plus 3. Let's get rid of that plus 3. I don't like that guy. All right, so that's an adding 3. All right, so how do we get rid of numbers on one side? We use inverse operations. So what's the opposite of plus 3? Is negative 3. Okay, so minus 3 is the opposite of plus 3. So I went ahead and put my negative 3 up there so that I can make some 0 pairs. Wait a second. If I put a negative 3 on one side, I have to put a negative 3 on the other side. Remember, balance is the key. Okay, so once I put that up there, I can go ahead and eliminate my 0 pairs. There's 0 pairs on one side. A positive and a negative, a positive and a negative, and a positive and a negative. All right, so those are 0 pairs. We can get rid of those. And now we have x by itself. There is an x over here, nothing else to do to it. So our final answer is x equals whatever's over here. X equals negative 8 would be our final answer. So to do two-step equations, it's very similar. Okay, we start with our key, and then we look at our equation, 2x plus 3. Let's set up our little box here where we have a scenario where we're going to put 2 x's. This is one side of the equation. So this whole thing is going in this box, and this is going on in this box. So we have 2 x's. So don't mess up and go 2 and then put an x. That does not mean 2x. All right, that means 1 and an x. 1 plus x. To show 2 x's, we're literally going to put 2 x's. Okay, and then we're going to add 3. So we'll put 3 positives there. Okay, so that's why that's there. And then remember, this is the equal sign. This is our balance. On the other side, we need negative 5. Okay, this is going to look very similar here in a second because our last equation that we just did with the one-step equations was x plus 3 equals negative 5. Remember that? Well, if you look at this scenario, we have an x and a plus 3 and a negative 5. So the two-step scenario says we use GIMDAs and we flip it around and do it backwards. Okay, to solve, what do we got to do? We got to get the variable by itself, and we use GIMDAs here. Start at the bottom. Do you see any addition or subtraction? Okay. Yes, I have a positive 3, a positive 3. So we got to get rid of that positive 3 just like the last time. All right. So we are going to go ahead and do the 0 pairs. It's positive 3. So let's do a negative 3. But remember, whatever we do to one side, we have to do to the other side. So we add the negative 3 to the other side as well. And remember, get rid of those 0 pairs. And you're going to start hearing me say this, cancel it out. So the 0 pairs kind of cancel each other out, don't they? So we're going to go ahead and get rid of them. Okay. And last time we were done, but that was our first step. This addition and subtraction was our first step. These are called two-step equations. So there's a second step. To solve, get the variable by itself. There's no more addition and subtraction, but there is multiplication and or division. This is 2 times x. So we're going to do the opposite of that. Okay. And inverse, we're going to divide it. So look what we have. In order to solve this problem, we need to show the value of just one x. Remember the last problem had x equals, and then there's numbers on the other side? Well, in order to do that, okay, we have to make 2 equal groups because we have 2 x's and we have all these guys over here. We need to make 2 equal groups. Okay, so I took those and put them into 2 rows of 4. Okay, and so what we're doing is we're basically dividing this by half. We're telling ourselves, dividing by 2, I mean, basically telling ourselves we want to know the value of just one of these x's. And so 1x equals 4. So our answer is x equals negative 4. All right, because 1x is equal to negative 4, and this other one is also equal to negative 4. So we know we used division correctly. So x equals negative 4. Okay, let's try a division problem because these are always a little bit harder. We already know the addition and subtraction because that's 0 pairs, right? Do the inverse. So here we have x divided by 2 minus 2 equals 2. Holy 2. So here we have x minus 2 equals 2. So we put the x up here, and then we subtracted the 2. What we haven't done yet is shown the minus 2. And so for this equation, we only have half of an x. So x divided by 2 is half of an x. So we're just going to turn this into a half of an x. Now we have half of an x divided in half, minus 2 equals 2. All right, so what do? We do GIMDAs backwards. To solve, we get the variable by itself. Do you see any addition or subtraction? Yes, we have minus 2. How do we get rid of that? We want to move that minus 2 to the other side. Well, we use the inverse. We create some zero pairs. If we have negative 2, let's do plus 2. That's the opposite. Whatever we do to one side, we have to do to the other side. Okay, and then we get rid of our zero pairs or cancel it out. They're gone. So now we only have one step left. To solve, we need to get the variable by itself. By the way, we just did one step. Adding 2 to both sides was first step. Second step is dealing with the multiplication or division. Do we see any division? Yeah, we got x divided by 2. Right now, a half of an x equals 4, okay? Okay, so we have to do the inverse. We need to show the value of a whole x. So half of an x equals 2. Let's double the half, okay, so that we can get the value of a whole x, okay? So half of an x equals 4. 2 of those half x's, so if I have a half and a half, that equals a whole. So now our whole equals all of these. So 1 whole equals 8. Okay, so now we have a whole x, so x equals 8. Not too shabby, huh? How do we model and solve two-step equations? Let's fill in the blank. To solve equations, we need to move numbers from one side of the balance to the other side. The key to moving from one side to the other is inverse operations. Okay, there's going to be 2 steps. You're going to have you're going to have an addition or subtraction first, inverse to get rid of them. Then you're going to have a multiplication or division second, inverse to get rid of them. So you get that x by itself. Next, with equations, we do order of operations backwards. So we start at the bottom with addition and subtraction and move our way up. How do I get rid of the positive or negative squares on the same side of the variable? You use zero pairs to get rid of the variable by itself. So how do I get rid of the positive or negative squares? Remember that's plus 1, minus 1, plus 7, minus 7. How do we get rid of them? We do the opposite, inverse, which makes us create zero pairs. That's how we get rid of them. And then once we do that, we get to the multiplication or division is the key to find the value of one variable. So once we get to multiplication or division, the first step gets rid of addition or subtraction. Once we get to multiplication or division, the key is to just get down to one variable, not a half a variable, not 3 variables. All right, so you guys are ready to rock and roll. It's a little bit of a challenge, but I think you're up for the task. What do you do if your dog steals your spelling homework? You just take the words right out of his mouth. Nailed it.